Okay? So we've got to figure out how do you go from 3 to 1? Yeah, divide by 3. So what do you think you're going to do on this side?
Divide that way.
Divide by 3.
You get 5.
So x is going to be 5. Beautiful. Over this side, what am I going to do here? How do I go from 20 to 10? Divide by 2. So what am I going to do on this side?
Divide by 2.
Awesome. Divide by 2. So the important thing to know when simplifying ratios is that you just figure out what has been done to one particular side. It might not always be divided, it might be multiplied, but you just figure out what has happened to go from the top number to the bottom number and then do the same to the other side. So it might be multiply, it might be divide, whatever. Yeah, just do the same to the other side. Oops, I never wrote what x is equal to here. X equals 4. So now I want to recognize a graph of a direct versus an indirect relationship when we're talking about proportion. So if I was to say US dollars compared to Australian dollars, and I was to graph them, for every $1 American equals however many Australian. And that amount doesn't change, so they're in direct relationship. So the graph would look like this. It would be a perfectly straight line heading up in that direction. Yeah? Whereas indirect, does anyone remember what an indirect relationship looks like?
Down.
Ooh, sort of,
Like in the middle.
but it's not a straight line. It's a curve, like that. So all you need to know as far as direct and indirect goes for your exam is how to draw them. Okay, so next up we want to look at how we calculate the rate that a person has travelled if this is their graph. So we want to be able to read a graph and be able to calculate rates from this graph. So here I've drawn a graph where, I don't know, a cat is walking, I don't know what, a dog is walking. Down the bottom is time. Why does time always go down the bottom? Because it technically, yeah, you're right, time doesn't stop, but it is, I heard it come from over there. Dependent is independent. Fantastic. We are going to get to dependent versus independent, but time always goes on the bottom because it is our independent variable. And here I want to be able to find out how fast this dog was traveling. Any ideas as to how I might do that?
You look at the time and then distance.
Great. So, how do I look at time and distance?
You just follow the numbers on the other side.
Yeah, great. So all I'm going to do is I'm going to pick one point off of this graph. Because it's a direct relationship, because it's one of these, what it means is it doesn't matter which point I choose, I'll still get the same answer. Whereas if I was doing an indirect, I'd get all kinds of stupid answers. See how this is a perfectly straight line?
Yes.
Direct relationship means the rule, the proportion rule, which we're going to talk about soon, doesn't change. So I can pick any point along here. Any ideas? We want to pick this one, this one, this one, this one, or that one.
We want to pick
The third one?
Yeah.
All right. 1, 2, 3.
Please.
So just for my own personal enjoyment, I like to draw a dotted line to that point. So, how far has old mate travelled? Yes. 30. Fantastic. So, it's 30 meters. And how long did it take them? An hour. Or 60 minutes.
Oh, that's the one that.
So, now what I want to figure out is how far I want a measurement in meters per 1 minute. So, any ideas as to how I do this one?
Maybe divide it.
Great. So, I have a look. How do I go from 60 to 1? Any ideas? Divide by 60. So, what am I going to do over this side? Divide by 60. So, how many 60s fit in 30? Point
0.1.
So 30 is what of 60?
Half.
0.5.
Yeah,
Yeah, so it'll be 0.5. they'll be traveling 0.5 meters per minute. So they'll be traveling half a meter.
Let me draw that.
So this will work because it's a direct relationship. We'll get the same answer regardless of which point we choose. Do you want to do another one on this graph just to make sure we get the same answer?
Yeah.
All right. Let's choose a different point. Let's make this next one purple. Which point should we choose? We've already done 3, but we've got 1, 2, 4, or 5 left. 4? We'll do 4? Okay, 4 it is. So this is our 4th point, dot, 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 all the way down, dot, 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 all the way across.
Wait.
Cool. So, how far have they traveled in distance? 40 meters. And how long did it take them?
About 80 minutes.
Yep, 80 minutes. So they've travelled 40 meters in 80 minutes. Cool. So, how do I go from 80 to 1? Great. Divide by 80. What am I going to do to the other side? Divide by 80. So, how many 80s go into 40? Yeah, 0.5. Because 40 is half of 80. Therefore, they've been travelling 0.5 meters per minute. So for every 1 minute that passes, they're going half a meter. Now, what we want to do here, the most difficult thing about a question like this is figuring out how to turn it into something that looks like this. So Mary is mixing green paint to make green. Mixing green paint. To make green, she uses blue and yellow in a ratio of 4 to 3. If she makes 90 litres of green, how much yellow did she use?
Maybe we times it.
So, what two colours are she using?
Yellow and blue.
So she's and in what exact order are they written in the question? That's very important. What
Blue
order
and yellow.
are they written? Fantastic. So blue,
And yellow.
yellow, and she's trying to make green. Green. Okay, fantastic. So that's our first step done.
Yeah.
We've got. It's very important that in the question that you read the question and put them in the right order. So it's blue to yellow. So how much? What is the ratio for blue?
4.
What is the ratio for yellow?
3.
Change this to something that divides nicely. Okay, sorry. So I've changed it now. Sorry, so that it divides nicely. We'll get a round number. And how many litres of green is she trying to make?
70.
Cool. But how many parts is our 70 litres broken up into?
7. No. Actually, I don't know.
So how many parts of paint has she used to mix?
No.
If she uses 4 parts of blue, 3 parts of yellow.
Also 7.
Yeah, she uses 7 parts. I'll use the next one. So if 7 equals 70 litres, how do I figure out what each part is going to be? How do I go from 7 to 70?
Divide it. Actually, times it by 10.
So if I've done that to one part, what am I going to do to the next part?
Times that by 10.
What am I going to do to this one?
Times 10.
So 4 times 10 is? 3 times 10 is? And then together they add up to 70. And what colour am I trying to find out how much she uses?
Yellow.
Yellow. So that's 30 litres. Alrighty. Our next worded problem. Jimmy plants 160 pink, red and yellow rose bushes in a ratio of 4 to 10 to 2. And we want to find out how many pink ones did he plant.
Go in order.
So, what are my colours? Pink or
Red and yellow.
Cool. What's my ratio for pink?
4.
What's my ratio for red?
10.
And yellow? 2. Great. And how many parts are there in total?
3
So 4 plus 10 plus 2
is 16.
16. So all up there's 16 parts.
Oh, you can times that by 10 as well.
Great. So all up in total, hold on, I'll write total up here. 16 parts. So in total, how many bushes did he plant?
10
160.
times 10.
Great. So spot on. I'm multiplying by to get from 16 to 160. I'm multiplying by 10.
Do you multiply by 10 every time?
Yep. Only for the questions that I make up because I started creating questions. Your ones in the exam might not require you to multiply by 10.
How do you know what's multiplied by?
You figure out how you go from the top number to the bottom number. You know what? I'll make up a question that's not by 10 for our next example. So times 10 times 10 times 10. So 4 times 10 is 40. 10 times 10 is 100. 2 times 10 is 20. And hopefully, if we're good at maths, they should add up to 160. Alright, next question. So McDonald's sell 3 different types of family boxes. One for $20, one for $35, and one for $40. In one day, they sell 115 boxes in a ratio of 3 to 11 to 9. How many of each box did they sell? So, any ideas as to how we get started?
You have to find how many parts.
Cool. What's the first box? What's the first type? $20 box. What's the next type?
$35.
And then the next one is $40 box. And how many boxes did they sell in total?
115.
115 boxes. Oh, you know what? I'll just leave that as total. Coolsies. So, how many $20 boxes did they sell? The ratio. 3. $35 and $40 boxes?
9.
Cool. You know what? I'll write this down. Have I lost anyone so far? No, we've just taken the information in the question and laid it out like this. Now, how many parts are there? 3 plus 11 plus 9?
23.
Cool. Now, how many boxes did they sell in total? Yep, 115. Now, can anyone tell me how many times 23 goes into 115? Nice, it's 5.
Really? Yeah.
So to go from there to there, it's multiplied by 5. Yeah? Any questions about how we figured that out? No? Coolsies. So if this is multiplied by 5, what am I going to do to each of these?
Multiply by 5. Oh, I get it.
Times 5. Times 5. Times 5. So 3 times 5 is 15. 65. 9 times 5 is 45. Cool. So 55 plus 45 is 100 plus 15 equals 115. Spot on. Alright, cool. So next up we want to look at proportionality statements or proportion statements. So it looks like this. It's y equals kx. Now y is whatever your dependent variable is. And x is your independent variable. So for example, if we're looking at how much money you earn over time, money would be your y and time will be your x because time is always independent. Cool. So in the question, distance is proportional to time. So it tells us that we're going to be using this because they're proportional. When d is equal to 12 and t is 3, write a proportion statement linking d and t. Okay, as horrifying as that seems, I've thrown a worded question in here for you just to get a little more practice with those. But basically we want to write y equals kx at the very end but we want to have a value for k. So essentially, we're trying to find k. So I have a formula, which is y equals kx, and I'm trying to find k. Now, my variables are distance and time. Which one is my y? Which one is dependent on the other? Does time change depending on how much distance you've traveled, or does distance change depending on how much? Awesome. So distance, so d. And we don't know what k is, that's what we're trying to find. And what's my x? Yeah, time, t. Cool. So it's a lousy looking k. Awesome. Now it gave me a value for d. It told me what d is equal to. What's d equal to?
12.
12. Still don't know what k is, but it tells me what t is. What's t equal to? 3. K and t, how are they together? Like, what has happened to those two to merge them together? Yeah, they've been multiplied together. So there's a little imaginary multiplication sign in here. Now it's an equation. How do I move the 3 to the other side? Yeah, great. I'm going to divide by 3. Divide by 3. How many 3's fit into 12? 4. So k is equal to 4. Alright, but I'm told that I have to write a proportion statement linking d and t. So I have my k, but now what I want to write is this again. So d equals something t. So I was trying to find what k is. What is k equal to? 4. Cool. So instead of my blank gap, I'm going to write 4. And that's the statement. That is how the relationship is. So now, no matter what number I put into d or t, I can calculate what the other one is going to be equal to. Alright, next up we have a question that says, students' love of maths is proportional to the frequency of their lessons. No, frequency is a bad word. You know what? No, I'll leave this frequency. If a student rates his love as a 4 and the frequency is 160 minutes, I don't know, in a week. I don't know, per fortnight. Per fortnight, write a proportion statement. Okay, so what's the first thing I do? What am I trying to calculate here? What letter am I trying to find? I've got frequency. I'm trying to find k. Fantastic. So y equals kx. K is what I'm trying to find. This is what I'm trying to calculate. So, what would be the independent thing here? Is their love? Does their love change depend on the frequency that they're there, or does the frequency that they're there depend on the love that they have for the subject? Awesome. Time. So frequency would be our x. So what letter shall we call that? We'll call that F. We don't know what K is yet. And what would be our dependent variable? Which one changes depending on the other? Love. So we'll call it L. So the more often they have maths class, the more they love it. The less often they have maths class, the less they love it, which is totally true. I know you guys love having me for double periods. Okay, now it tells us, what did the student rate their love as being? 4. And then what? Oh, hang on, this isn't going to work
The
out.
frequency is 160.
Yeah, you know what? We'll get a decimal, but it doesn't matter. Okay, and frequency was 160. So now what am I going to do?
Find x.
I'm finding k. Sorry, it's my terrible handwriting. How do I break k and 160 up? Yeah, I'm dividing. So I'm dividing by 160, and I'm dividing by 160. So k is going to be, let's see, k will be 1/40. Okay, now I figured out what K is. What do I need to do? I need to write a proportion statement. So even though I've calculated K, I can't stop there. I have to rewrite this using the letters and using K. So therefore, L is equal to 1/40th. So now, no matter what number I put in L or F, I'll be able to calculate the missing number. Alright, our next question is using this statement, I need to find L when F equals 80. So, what should I do? What am I trying to find? L. So L stays the same, because that's what I'm trying to find. 140. And what's F? 80. Now, how are these two joined together? Just out of curiosity. Times together. So now I'm going to multiply those together. So 80 times 1/40 will give us 2. So I just type that into a calculator, it'll give you the answer of 2. Yeah? Alright, now let's do this one. Much easier, doesn't have a fraction in it, won't scare you for life, won't scar you for life. Alright, so we want to find M when R is equal to 9. This is my proportion statement. What should I do? So, M stays the same because I don't know what that is yet. 11 doesn't change. And then how are 11 and R start together? Multiplied. And R is? 9. Cool. So 11 times 9 is? 99. There we go. We found M. Happy days. Alright. You also might have to find it in reverse. So we need to, for this question here, we want to find S when B is equal to 24. So I'm going to rewrite this using these numbers. So B, instead of writing B, I'm going to write 24 is equal to 2S. S doesn't change because I don't know what that is yet. How do I break up 2 and S? Great. Divide by 2. Divide by 2. How many 2's go into 24? 12. Therefore, S is equal to 12. Next one on the list is being able to determine independent and dependent variables. So basically, we're just trying to figure out which one changes the other. So for the first one, if we're looking at the speed of service versus the number of people serving in the canteen. If you think about when you go to the school canteen, if they've only got one person in there, the service is kind of slower. If they've got 2 people or 3 people in there serving, the service is faster. So which one is independent? Daniel?
The speed depends on the number.
Awesome. This one's dependent and this one is independent. Great. The number of people that are there changes the speed. Great. The price of burgers versus how many are sold. Do you decide what to buy based on how much money you have? Yeah, awesome. So the more expensive something is, the less people will buy it. So, does the price of burgers change depending on how many they sell, or does how many they sell depend on the price? Awesome. So which one's independent? Price. All right. Distance versus time, easy one. We always know that time is independent. Alright, temperature versus ice cream sales. Does the temperature change depending on how many ice creams the shop is selling? Or does the number of ice creams sold change depending on how hot it is?
Ice cream.
Ice cream don't change.
Awesome. So temperature is independent. The temperature does not care about your plans to buy ice cream or not. And this one's
Temperature can't change.